introduced our matrix, or what our matrices look like, and just some simple addition, subtraction, and multiplication that we could do with them. So we didn't really do a whole lot with our matrices. Today, we're actually going to solve our systems of equations. So we're going to solve a system by using what we call an augmented matrix. So what happens, it's a matrix consisting of the coefficients, so the numbers in front of our variables, and the constant terms of the system. So just the numbers on the other side of the equal. So for example, here's a system. Sit right? Two equations with two variables, x minus 3y equals 8 and negative 9x plus 2y equals negative 4. If I wanted to write this in a matrix, I just write the coefficients and the constants. So there's an imaginary 1 in front of this x. So really I'm just writing the coefficients. So I'm going to write 1, negative 3, negative 9, and 2. And then I'm going to write the constants, 8 and negative 4. But I'm going to space those constants by a dashed line to show that those are what it's equal to. So all I did is I drew a matrix using the coefficients, right? So we can see that the imaginary 1 in front of the x, so I put a 1 in the top left. Then I had a negative 3, so I put a negative 3. And then I have an 8, so I put an 8 all in the first row. And the equal sign, I use this dashed line to represent the equal sign. And the same thing with the second row, negative 9, 2, and negative 4. So here's my augmented matrix. So first step, that's all we're going to do. We're going to take a system and let's write it in an augmented matrix, just so we get used to that before we solve it. So let's grab a couple equations here, and let's write in an augmented matrix. So number 1, put my little bracket so I can have enough room for 2 rows. First row looks like I have a 4, a 2, a positive 2, and a 22. Second row, I have a negative 2. Remember, it's an imaginary 1 in front of that y, so 1 and a negative 5. And we push the dashed line to represent where that equal sign's at, and then we end our bracket. So there's an augmented matrix. Pretty straightforward. Same thing with number 2. Put my left bracket. X always comes first, so I got 2, the coefficient on x. Coefficient on y, it's an imaginary 1, so 1, and the answer of 10. Well, the x always comes first, right? The coefficient on x, so negative 3 right here. Well, there is no y, so what do you think we're multiplying y by? A 0, that's why it's gone, and then negative 18. And we throw our dashed line in there for the equals and end our bracket. So there was no y, so it must be a 0 on the coefficient, because 0 times y is 0, so it's gone. Right? I wouldn't write this for that second equation. I don't actually write this 0y because it's gone, so it's just out of there. So that's why I put the 0 in for its spot. But I have to put the 0 in the matrix, though. Otherwise, it won't work out when I try to solve it. Well, there's just some things we got to do to our matrix in order to solve it. And we have some rules we have to follow. And we have some elementary row operations. Basically, we can do the exact same thing that we did to our systems previously, but it just works in a matrix. So first thing we can do, we can interchange any 2 rows. Right? I can just switch row 1 with row 2. So for example, if I look at my red guy over here, I could just flip-flop the rows. I could put the second row first. I could go negative 2, 1, negative 5, and then 4, 2, 22. I could just flip-flop the rows, interchange. Okay? So there's one rule. Another thing I can do is multiply all elements in a row by a non-zero constant. So I can't multiply by 0 ever, but I can multiply by anything else. And really I could divide as well, because dividing is the same thing as multiplying by the reciprocal, right? Working back with our fractions, dividing is the exact same thing as multiplying by the reciprocal. Okay? So if I look back, let's take this block that I just made now. Well, let's say I wanted to multiply the second row by 2. I could do that. Multiply the second row by 2. The first row would not change, so it stays as negative 2, 1, and negative 5. And the second row would become 8, because 4 times 2 is 8. 2 times 2 is 4, and 22 times 2 is 44. You just have to make sure you do it to every single term in that row. Okay? So I can interchange rows. I can multiply a row or divide a row. It doesn't matter. Either way, you just got to do it to every single term in that row. And the last one, this is the one where it gets a little bit tougher. I can replace one row with the sum of that row and a multiple of another row. Replace one row with the sum of that row and a multiple of another row. So let's think about that. Let me get rid of this. Let's just go back to this red guy here once. So one of the things we're going to do, let's pretend I wanted to get a 0 in this spot. I wanted to get a 0 in that spot. Well, I would take 2 plus one number, right? I would take 2 plus what to get to 0? I'd take 2 plus negative 2, right? I would need to add a negative 2 to this. Well, so my rule, let's go back and read my rule. It says, replace one row with the sum of that row and a multiple of another row. So I'm going to use 2, and I want to add negative 2 to it. Well, I can multiply this second row by something and add it to the row above. Well, and if I want to get that 2 to a 0, I want to add a negative 2. So what would I multiply this 1 by to get it to a negative 2? I'd multiply by a negative 2, right? Because 1 times negative 2 is negative 2. So I can multiply every single term in this second row by negative 2 and add it on to the first row. Okay, I know a ton of you are lost right now. Let me write this again. 4, 2, 22, negative 2, 1, negative 5. This is how I write it to try to keep track. I'm going to take the second row, so I like to represent that as R2, second row. And I'm going to multiply it by negative 2. So I'm putting negative 2 in front. And I'm going to add that on to the first row. So I'm multiplying the second row by negative 2, and I'm going to add that onto the first row. So now I just think, if I take negative 2 times negative 2, I get negative 4. Or positive 4, I lied. Negative 2 times negative 2. If I take 1 times negative 2, I get negative 2. If I take negative 5 times negative 2, I get positive 10. And what do we say we're doing? We multiplied by negative 2, multiplied that row by negative 2, and then we add it on to this row. So I'm going to take 4 plus 4, which is 8. I'm going to take negative 2 plus 2, which is 0. I'm going to take 10 plus 22, which is 32. And the second row stays the same. When I do that, the row that I multiplied does not change, because I'm just multiplying and then adding it on to the next row. So that would stay the same. The second row would stay the same. Okay, I know it's kind of confusing. It'll make sense in just a second why that works and how it works again. So those are our 3 rules. I can just interchange rows. I can multiply by a non-zero constant or divide. And I can replace one row with the sum of that row and a multiple of another row. And we call this row reduction. Call it row reduction. And what we want to do with that row reduction is we want to get our augmented matrix into what we call the identity matrix, where it goes 1, 0, 0, 1. That's important, 1, 0, 0, 1. Because if I think about this, it's a system, right? It's like x plus y equals some number, and we have 2 equations. Well, if I think about this top row, this top row is really 1x, so x plus 0y, which is just gone, equals some number. And this bottom row would be 0x, which is gone, plus 1y, which is just y, equals some number. Well, isn't that the solution to my system, an ordered pair of x and y? So this would be what x equals, and this would be what y equals when I get it into an identity matrix. Because this top row is really x equals, the bottom row is really y equals. And that's why that augmented matrix works. Okay, I'm sure some of you are getting this and some of you are still having some trouble. So let's try an example once. Use an augmented matrix to solve the system of equations. So the first thing we have to do is write an augmented matrix. So I'm going to go ahead, put my brackets, negative 3, 2, 2. There's my first equation. Then I have a 1, right, imaginary 1 in front of that y, and 6. And then I put my dash where the equal sign's at. There's my augmented matrix. Well, here's the key. You don't want to frustrate yourself. I could start doing all kinds of things to try to get it to my identity matrix. Right, I want to get it to I want that left side to be 1, 0, 0, 1, right? So I have x equals y equals. Okay, so don't just start randomly doing things. Have some strategy to this. And I'm going to give you some advice on the best way to solve these matrices. The order you want to do this is, you always want to get the 1 in the top left right away. And then I like to do the U, I guess, for my aug. My augmented matrix, so I like to do what I call the U. So I get the 1 first, and then I go ahead and I get the 0 second, and then I get the next one, and then I get the last 0. So I make up myself a little U right here. That's the order I go in. That's going to save me a lot of time and a lot of headaches. Okay, if I try to get the 0 first, it's going to make it difficult. I want to start with this 1. I want to get a 1 in the top left corner, and then I'm going to work in the U. So first things first, what's the easiest thing I could do to this matrix to get the 1 in the top left corner? Well, I hope you see it. All I got to do is just interchange the rows, because then this 1 is going to go up top. So I'm going to interchange the rows. So I'm putting row 2 up where row 1 is at, and vice versa. I'm just switching them around. So perfect. I already got my first job. I got this 1 right in the top left. Perfect. Okay. My next goal is to get a 0. Okay, let's go back and look. So I'm working in the U. I want to go and get this 0 now, right below it. Well, how do I get that -3 to a 0? Remember, I can't multiply by 0. So I can't just multiply this second equation by 0. It doesn't work. I can't do that. So I'm going to have to add something to that second equation. Well, what do I want to add to -3 to get it to 0? I want to add a +3, right? So I need to multiply this first equation by something to get it to 3 so I can add it to the second equation. So I just look at this 1. 1 times what gets it to 3? Well, 1 times 3, right? So I want to multiply this top row by 3 and add it to the second equation. So I like to put it on the side so I know what I'm doing. I want to multiply the top row, so row 1 by 3, and I'm going to add it to this second equation. So that helps me tell. And then I always like to write below what I just multiplied, so I know what to add. So same thing, I take 1 times 3, and I add it to the second equation. I take 6 times 3, 18, and I add it to the second equation. And if we remember, the first equation does not change. Right? I'm not adding anything to that first equation. So the first equation stays the same, so I like to just write it right away. And then the second equation, start adding. So -3 plus 3 is 0. 2 plus 3 is 5, and 2 plus 18 is 20. Bring my dash line and my matrix. So there we go. I'm good. I got this first column done. I got a 1 and then a 0. Perfect. Okay? Just remember, it's always better to get the 1 first. So now I go back. The next thing I want to do is work in my U. So I already got the 1, I got the 0. So now let's go get that next 1. We'll go get that next 1. Well, I don't want to interchange, because if I interchange, I have to move the whole row, which means if I move these two together, I'd also have to move those two. So I don't want to interchange, because then I just lose my 1, 0 I just had. So how could I get the 5 into a 1? Usually when you get something into a 1, you just want to multiply or divide. Well, could I divide this second row by something? Yeah, how do I get to a 1? 5 divided by 5. I can divide by 5. I can do it to the whole row, which is the same thing as multiplying by the reciprocal. So I could multiply by 1/5 actually. Let's just leave it as division. It's easier to see. Divide by 5, so I just divide the whole row by 5. So first row stays the same, 1, 1, 6. Second row, 0 divided by 5 is 0. 5 divided by 5 is 1. And 20 divided by 5 is 4. Okay? And then the last thing we need to do is get the 0 on top, right? I need to get a 0 in place of that 1 right there. So how am I going to get that 0? Remember, to get zeros, we got to add, right? Multiply and add. So think about this. What do I want to add to that 1 to get it to a 0? What? I want to add a -1 to that 1. And how do I get a -1? What do I have to multiply this one by? I got to take 1 times -1. So I'm going to multiply that second row by -1, and I'm going to add it to the first row. So I just multiply every single term in the second row by -1. 0 times -1 is 0. I add that. 1 times -1 is -1. And 4 times -1 is -4. And then I add that to the first row. Leave the second row the same. I'm going to bring this guy up here. So 0 plus 1 is 1. -1 plus 1 is 0. Negative 4 plus 6 is 2. And then I leave the second row the same because I didn't add anything to it. And there we go. I just solved it, right? Because x equals 2, y equals 4. So the solution of my system is 2, 4. 2, 4. Now you're probably telling me, Mr. Russell, why don't we just use elimination or use substitution or something? I know that it's probably going to save us some time, but working with these matrices is going to help you out later, especially when you get to Algebra 2, when you work with some more things with your matrix. Okay, so it's important that we learn this. Let's do one more example. I'll go a little bit quicker here. So just follow the U. Solve your U. And I think that's going to help you. Go in that order. So draw my augmented matrix. So 3, negative 6, 36, 2, 4, negative 40. Put my dash for the equals. Okay, first things first. We want to get a 1 in the top left right away. Well, usually when we get a 1, I either want to interchange or multiply or divide. Well, interchanging doesn't help me to get a 2 up there. So I'm going to multiply this top row by, how do I get it to a 1? I'd have to multiply by, well, or divide by what? Divide by 3, right? 3 divided by 3. I'm going to divide by 3, which makes that first row, 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. And 36 divided by 3 is 12. Second row stays the same. Dash, dash, dash. Okay. Now we want to go right below that 1 that I just made and get a 0. Remember, to get zeros, you multiply the one row and add it to the next. So what am I going to multiply row 1 by? Well, I want to get this to a negative 2, so I can add it onto that 2. So 1 times negative 2. So multiply that first row by negative 2, and then add it to the second. So negative 2 times negative 2 is positive 4. And 12 times negative 2 is negative 24. And we add that to the second equation. First one stays the same, right? Because I didn't do anything to it. That's why I like to write this here. So I know I'm only applying it to this, that row. So 1, negative 2, 12 stay the same. Then 2 plus negative 2 is 0. So we're trying to do 4 plus 4 is 8. And negative 40 plus negative 24 is negative 64. Bring my dash down. Bracket, okay. Just working the U. I got the 1, I got the 0. Now turn that 8 into a 1. Turn the 8 into a 1. And when we try to get 1s, we usually multiply or divide, don't we? So 8 divided by what gives me 1? 8 divided by 8. So I'm going to divide this whole row by 8. So first row stays the same. 1, negative 2, 12. 0 divided by 8 is 0. 8 divided by 8 is 1. And negative 64 divided by 8 is negative 8. Good? And so the last thing, we got to get that negative 2 turned into a 0. So let's just I'm going to bring this right over here. So let's think, what do I got to do? Remember, to get it to a 0, we usually multiply the other row and add it to the other one. So negative 2 plus what gives me 0? Well, negative 2 plus 2. And 1 times what gives me 2? Well, 1 times 2. So I got to multiply that second row by 2 and add it to the first row. So 0 times 2 is 0. 1 times 2 is 2. Negative 8 times 2 is negative 16. And we're going to add that to the first row. So I have 0 plus 1 is 1. 2 plus negative 2 is 0, which we're trying to do. Negative 16 plus 12 is negative 4. Then I still have the second row the exact same. I didn't do anything to it. So I just solved my system. So x equals negative 4, y equals negative 8. Okay, so I know it can seem complicated. Just take your time, follow your rules, and if you follow the order of the U, you won't frustrate yourself. But if you don't follow that order, if you start randomly finding parts of your identity matrix, if you try finding a 0 first instead of the 1, you're going to run into some trouble. I guarantee it. Okay? So I'm sure there'll be some questions, but the best thing is just get some practice on your own. So really look through these examples.